In this video, we'll look at how we control servo motors with our Arduino. Servo motors are small electric motors which are commonly used in robotics and in model aircraft and other hobby sort of activities. They're fairly high torque and precisely rotate a small armature with about 170 degrees or so of motion. The cable on the servos has 3 wires or 3 pins. We have power, which is generally red or yellow. We have ground, which is generally brown or black. And we have our signal one. This is where we actually set and control the position the servo arm is going to be in. To control the position of the servo, we use pulse width modulation. If you're unfamiliar with PWM, take a look at the other video on PWM which describes what it is and how it actually works. For our servo, the period of the pulse we're transmitting should be 20 milliseconds, and the on time should vary from about 1 to 2 milliseconds, somewhere within that range. It really depends on the servo. Now if we supply an on time somewhere in between here of about 1.5 milliseconds, we should approximately have the arm in the center position. As we go closer to 1, the arm will move in one direction, and as we go closer to 2, the arm will move in the other direction. Now fortunately for us, there's a special library in the Arduino that takes care of all of this. So all we need to do is essentially declare it and set it an angle, and it will move to that angle. How convenient. Well, to make all this happen, the servo needs to be connected to either pin 9 or 10 on the Arduino. These pins have special hardware in them called timers, which take care of the pulse width modulation generation for us. So let's go through an example of driving a servo motor with our Arduino. First, what we need to do is we've got a special library in our Arduino software that allows us to specifically drive servos. So we need to reference that at the start. We say hash includes servo.h. It says we want to use this special library. Then we need to create a servo object. Now we need to create one of these for each servo we use. We're going to use one, so let's call it servo1. If we had more servos, we'd call them servo2, 3, 4, or whatever else you'd like. Of course, we need our setup function. In our setup function, essentially what we want to do is make this servo active, actually start driving it. So we say servo1.attach, and we specify the pin number. Now our servo is connected to pin 9, so we specify pin 9. That will start driving the servo. Now we need to actually make it do something. So what we'll do, we'll drive the servo to one angle, then we'll delay for a little bit, we'll drive the servo to a different angle, and we'll delay for a little bit. So we use the command write to write a particular angle to the servo. So we'll send it to 20 degrees, then we'll delay for 1.5 seconds or 1500 milliseconds, then we'll set it to a different angle. 150 degrees. Okay, we'll compile this and see what it does on the actual hardware. Here's the circuit which has been connected up. The servo motor is connected to our ground, our 5 volts on our Arduino, through our rails, and then through to pin 9, which is supplying the signal, making it move. We see every 1.5 seconds the servo goes from one of its angles to the other angle. That's all dependent on where we actually install this little servo horn here. Here we see the signal that's being fed into the servo. The on time is varying between approximately 1 millisecond and 2 milliseconds, giving a fair bit of deflection in the servo. For those doing the robotics project, you'll see some servos that have been modified for continuous rotation. This means they can spin freely and continuously in either direction, not just the 170 degrees or so that we had previously. In this case, the pulse width modulated signal doesn't control the angle of the servo anymore, the angle of the arm. It controls the speed of the rotation of the servo. Now if we get it to its center point around 1.5 milliseconds, it will be off. If we move greater than this 1.5 milliseconds approximately, it will turn in one direction, and if we move less than, it will turn in the other direction.